Friends, welcome to my YouTube channel. Dhanesh here. Let's discuss on tokenization. So this is the third video on natural language processing. Today we are going to discuss tokenization using TensorFlow and Keras. So this is a simple introduction to NLP, natural language processing. This is the this is a beautiful equation. NLP is equal to NLU plus NLG. NLU, natural language understanding. NLG, natural language generation. See, NLG is an important part of NLP. NLU is responsible for understanding the content, and NLG is responsible for generating the content. So this is a simple introduction, and this is the pictorial representation of NLP, that is NLU plus NLG. So how do we build an NLP pipeline? The different steps involved are sentence segmentation, word tokenization, stemming, lemmatization, identifying stop words, dependency parsing, POS tags, named entity recognition, and chunking. So we have in the first video we discussed in detail about these things. You can see the playlist and you can watch those videos. Today, we are discussing about tokenization. See, it's in NLP, tokenization is really important. Tokenization is the process of tokenizing or splitting a string text into a list of tokens. One can think of token as part like a word. A word is a token in a sentence, and a sentence is a token in a paragraph. Tokenization is essentially splitting a phrase, sentence, paragraph, or an entire text document into smaller units such as individual words or terms. Each of these smaller units are called tokens. See why tokenization is important. Let's take the example of English language here. Think of a sentence. Child is the father of a man. This is a beautiful quote by William Wordsworth, the great poet. Child is the father of a man. Before processing a natural language, we need to identify the words that constitute a string of characters. This is important because the meaning of the text could easily be interpreted by analyzing the words present in the text. Methods to perform tokenization. There are different methods available there. Tokenization using Python split function, using regular expressions, using NLTK, using Spacey library, using Keras and TensorFlow, using GenSim. So the tokenization using NLTK, that's the second video. It's already there in the playlist. You can watch how we can do tokenization by using natural language toolkit. You can download it's in Python, and you can download it and do that. So it's the implementation is there in the playlist. You can watch it. Now tokenization using TensorFlow and Keras. You see, when dealing with pictures, we have pixel values which are numbers. See, when we discuss about convoluted neural networks, you can watch those videos, even recurrent neural networks, LSTMs, GRUs. We have videos on those, GRUs, LSTMs. At that time, we have taken the pictures. So the smallest value in the unit is pixel for a picture. When dealing with text in NLP, in natural language processing, we have to deal with text. It has to be encoded so that it can be easily processed by a neural network. The text is to be encoded. That's really important. When we label each word in a sentence, we begin to see similarity between sentences. Hence, we can begin to train a neural network which can understanding the meaning of the sentence. Because how do we label it? For example, I am writing a sentence. John is an engineer. At the same time, John is a father. So John is, so these two things, if we are labeling, it is labeled as John is labeled as 001. So the same label we can repeat here, and we can the computer can, the machine learning algorithm can, the machine learning model can understand the similarity between sentences. Is, again it is 002, we are labeling. So here also it is repeating. So the model can understand the similarity between these two sentences. So this is the importance of labeling. So hence we can train a neural network which can understand the meaning of the sentences. So when we label, we begin to see similarities between the sentences. So this is tokenizer. It's an important class from Keras. Using a tokenizer class, we can label each word and provide a dictionary of the words being used in the sentence. We can come up with a dictionary for that by using the tokenizer class. The method we use for this labeling is fit underscore on underscore text. Method is used to encode the sentences. So this is the approach we do in the program. So let's see a program in using TensorFlow and Keras. So I will show the program. So this is the Spider IDE. So I have installed Anaconda. On top of that, I installed TensorFlow and Keras. So when you go to the Anaconda window and when you type Spider, you will get this window, this IDE, this integrated development environment. So this is a IDE I am using. So you can see the program here. It's a simple program. Import TensorFlow as TF, and from TensorFlow import Keras. Then this is really important. This we need to have to look into. From TensorFlow .keras preprocessing text. From here we need to import text to word sequence. This is the one thing we can use, text to word sequence. I already told tokenizer. This is the tokenizer class we have to use. See, first I am going to use this part. See, I have taken a string. See, quote is success is a journey, not a destination. It's a beautiful quote. You might have heard of it. See, success is a journey, not a destination. So I am trying to tokenize that sentence by using this piece of code. Result is equal to text to word sequence. Then I pass this string code, then print result. Let me see what would be the output from here. I am trying to print it. See, I'm trying to run this. You can see the entire program is run here. See, you can see here success is the first token. Is the you can see a list here. Tax success is a journey, not so it is tokenized. So this is the way you can tokenize a sentence. Even with NLTK, we have tokenized the same part by using NLTK. You can see the previous video in the same playlist. So this is the process of tokenization. See, now if you want to get the number of words, the word count, you can use t is equal to tokenizer. This method you can use t dot fit on text. Then again we will pass this string quote. So the quote is the string. Then if we use this t dot word underscore counts, then this t is the tokenizer. We pass the t is equal to tokenizer. If you want to get the word underscore counts, see it will print the number of words there. It will see, it will print how many times it is repeating each letter. See, yes is repeating 5 times here. You can see success is a journey, not a destination. In that sentence, s is repeating 5 times, u is repeating 2 times, and c is repeating again 2 times. So each letter, how many times it is repeating, this piece of code will give you. So this is a very beautiful library. You can play with this, you can do anything with this libraries. E is, it is repeating 3 times, I is repeating 3 times, j all this, how many times it's repeating. So this is one use of TensorFlow and Keras, the tokenization. Now we have discussed about the labeling part. So we can label, we have discussed here. See, when we label each word in a sentence, we begin to see similarity between sentences. Hence, the neural network model can understand the meaning of the sentence. That's really important. So we are going to see how the neural network will identify these things. So here I have taken one list. It's sentence. It is a it's a list. He is John, he is American. So this, it contains two sentences. So I'm going to I have created the tokenizer from this class tokenizer. Inside that, I pass this num underscore words is equal to 100. Then I am calling the method fit underscore on underscore text. I pass the sentence here. Then word underscore index, tokenizer dot word underscore index. So this will give the index labeling to this piece of code, will give the labeling for he's John, he's American. So to that sentence, this will do the indexing part. In the same way, I have taken another set of sentences. This is sentence underscore 2. This is a next list. John is an engineer, Sam is a doctor, William is not an engineer. So how it will handle a labeling here, how it will be doing the labeling here. So that's what we are going to see from this. Again, the same piece of code I have repeated. So how the program is doing these things. So we will run it again and see it, how it is doing it. It's already, you can see the result there, but we will run it once again. So this is a success. This is the tokenization part. Here it is giving the count. See, here you can see from here, this is the part. He is John. See, the first he, that is taken as one. The he, it is common to both the sentences. If we see here, he is common to both the sentences. So it is labeled as one. So it is common both. Is also common. So it is labeled as two. But John is different, so John is labeled as 3. American is different for both the sentence, so it is labeled as 4. This is the way the network model, the neural network model can understand the similarity between sentences. But that's the way it is labeled. But when you come here, lot of difference is there. So the network model has to use more labels, because is common. That's why it has taken is first. See, here John it is, here it is Sam, here it is William. So here is common, so it is labeled as is as one. Now Anne, is it repeating? No, it is repeating. Anne is also repeating. That's why it is taken as the two. It is repeating. Anne is repeating. Then engineer is repeating. In this sentence, sorry, this sentence engineer is there. This sentence also. So engineer is labeled as 3, and it can use in both the sentences. John, it's not repeating. So John is 4. Sam, it's not repeating. It's 5. A. A is not repeating, so it's 6. A doctor, it's not repeating, it's 7. William, it is not repeating, it is 8. Not is there, so it is 9. So like that, if it is repeating, it will take in the beginning itself and it will label. So this is the process of labeling. So what is the use of labeling? We already discussed. It's the neural network model can understand the similarity between different types of sentences, and it can understand what exactly is happening in the whole paragraph or whole text, what it is written like that. The network can understand it, and it can give information to the to us. So that's the importance. So this is about the tokenization using TensorFlow and Keras. So we have done the tokenization using NLTK. Now we have done with TensorFlow and Keras as well. Thank you. Thanks a lot. Please like, share, and subscribe. Thanks a lot.